Hello. This lesson is about writing algebraic expressions. This comes from the packet that is entitled pages 38 to 51. And let's take a look at what we're going to be learning today. So algebraic expressions and formulas. At the end of this packet, you will be able to define the variable, coefficient, algebraic expression, and word expression. Write algebraic expressions from words and models, and write word expressions given the algebraic expression. Don't worry, this will all make sense after the lesson today. Simplify algebraic expressions, evaluate algebraic expressions by substitution, and use geometry formulas to find the perimeter to the area, the circumference, the volume of polygons, and other different shapes, including prisms. So let's get started with a few definitions. So let's scroll down a little here. So some definitions you have to be aware of. A variable is a letter used to represent an unknown number. So like the letter X is used frequently. Some other ones might be N, that's used a lot as well. The coefficient, that is the number that a variable is multiplied by. The coefficient is a number in front of the variable. So for example, if the variable is X, the coefficient might be the 3 in front of the X. That means 3 times a number, an unknown number. Algebraic expression, the next one, is a number sentence with one or more operations of addition, subtraction, multiplication, or division. And a word expression is just using words to describe algebraic expressions. So let's get started with our packet. I want to start on page 38. So let me pull that up for you. And right here, algebraic expressions and formulas. So you'll be able to read this if you'd like. This is what I'm going to be going over. So let's start with writing an algebraic expression for each word expression. So this is written in words here, and we want to write it in numbers or operations such as adding, subtracting, multiplying, and dividing signs. So n minus 8, write an algebraic expression for that. So how would we do that? We would say n minus 8, just like that. Okay. Number 5, let's take a look at that one. That one says 7 times x. So when you do multiplication with variables, you just write 7x. That means 7 times x. You don't put the times in the middle. It would kind of look weird to be like 7xx, and that gets weird. So they stop putting the times symbol in between. Number 7, here these, scroll up a little bit. Number 7, write a word expression. So now we're going to do the opposite for each algebraic expression. So we have 5x, so that is 5 times x. Okay, and number 10, let's do number 10. That is m, now that little line means dividing, right? Divided by 2. Not 2 divided by m, it's m divided by 2. Okay, let's clear our drawings and move on. Let's go to, I want to look at parentheses for a minute on page 39. So before I even bring this up, I want to move this away for just a moment and talk about it. So a parenthesis, here, parentheses, have a certain order that things need to be done in, right? And they mean different things. So for example, if you have 2y minus 7, that means 2y minus 7. That's different from 2y minus 7. This means 2 times the quantity, and I'm going to put that in big letters, y minus 7. And I'm going to stretch that out so it's not all run around here. There we go. So that means, so the parentheses, the thing that's in the parentheses is called a quantity. So don't get that mixed up. That's solving a whole different way. That's saying 2 times whatever that quantity is. So for instance, if y was 10, in the first equation, let's see what that would come out to be. If I said y was 10 and I substituted that in, I'm going to use a different color here and draw. Oh, I didn't want to do that. I'm going to keep that red. Oh, pooey. Redo. Okay, let's switch this back to red. Now it won't go back to red, so we'll leave it that color. Anyways, so 2y minus 7. So we're going to put in 10 for y. We're going to say y equals 10. So if I plug that into the first equation, I get 2 times 10 minus 7, right? So that's the same as 20 minus 7. That's 13, right? That would be 13. Now the second equation, if I plug y equals 10 in, I get 2 times 10 minus 7. So what do I really get? I really get, first we do what's in parentheses. So I really have 2 times 10 minus 7, or 3. I really have 2 times 3. So I really have 6 here. So you see how you get different answers depending on where the parentheses are in the equation. So here's another one, another example I'd like to give you. Some of these may be in your packet. Let's try 3, and in parentheses the quantity x squared. I have to put a little square there in a minute. Plus 1. Yeah, let me grab the squared key here. Change colors to blue and make a little square, because I can't do a little square in this thing right here. That's supposed to be a 2. So what does that mean in terms of words? That means, and now the little squared went away, that means 3 times the quantity x squared plus 1. And the squared will come back when I click on that. So that means 3 times the quantity x squared plus 1. So take a look at that. Know the difference and what that means. So let's take a look at some of these in our packet now. And some of those are examples in your packet now that I just did. So, okay, let's try to match some of these algebraic expressions with the equivalent word expression. So number 13, we have 4x minus 9, right? So that's 4x minus 9. Where is that? Over here. Right there, right? E. So that one is E. How about number 14? See if you can locate which word expression means the same as number 14. What'd you get? Okay, did you get the right one? Did you get H? Negative 2a times the quantity, here's the parentheses, a plus 7. So that one is H. And we'll do one more, number 19. Let's go all the way down to number 19 here. What is that? What word equivalent expression would that be? Did you get that one? Take a look. Be careful. Yes, that is C. Correct. That is letter C, because you have negative 2 times a squared, negative 2 times a squared plus 7. Okay, so you just have to look through them and see what is it exactly saying. Okay, let's go on to page 40. Now we're going to show some modeling of algebraic expressions. So I'm going to take a look at number 1B. They give you 1A, it's done for you, so you can take a look at those examples at home. We want to know what OD equals. So I'm looking at this equation, or this model right here. So what does OD equal? OD equals, let me change colors here. 2z, this part right here is 2z, and 4 more, right? That whole thing, 2z plus 4 equals the whole line going across. Let's look at C. What does CD equal? Right, it equals 5 plus x, right? Okay, very good. Let's take a look at 3C. Getting a little bit harder now. So I'm going to look at 3C right here. And they want to know what AB equals now. So AB equals, well, let's count. How many x's do we have? 1, 2, 3, 4, 5, 6 x's, right? So 6 x's, so 6 times x plus, what's this one? 8. Right, 6x plus 8 is what's being modeled there for us. Okay, and let's look at number 4C, the one right below it here. Clear this one. Let's look at 4C right here. Now they want to know what MN is. So MN is this part right here. How do we set up an expression for that? Well, we know that MN is equal to R divided by, how many sections is it broken into? Here's R, the whole thing. How many sections is it broken into? 1, 2, 3. So MN is equal to the whole R divided by 3 sections each. So that's one with division. Okay, let's get into a little bit, so give those a try. Let's get into simplifying an algebraic expression. Let's go over here a little bit. Now, simplifying is another way of saying combining like terms. There's a little bit more involved in that, but basically it's combining like terms. So for example, 5x plus 3 is really the same as the 5 plus the 3, 8x. So it's really 8x. You just add the coefficients in front of the variable. You don't say it's x squared. That's with multiplication, but we're not doing that. We're adding, okay? So let's clear that. So let's look at simplification with some perimeter problems. So let's look at number 1 right here. So we want to write an expression for that. So we are going to write, remember perimeter is adding up all the sides going all the way around. So we have one side that's called x, we have another side that's called x, and we have the bottom of the triangle called 7. So the perimeter altogether then equals, we're going to combine like terms. So we have 2 x's, right? So 2x plus 7. So that's what we want to write there is 2x plus 7. So simplifying, 2x plus 7 is the perimeter of that triangle. Let's do number 6, getting a little more complicated. I think I'll make a little bit of white space here so we can get rid of some of this and just focus on number 6. Okay, we want to find the perimeter of that rectangle. Well, they're giving us this side and this side, but they're not giving us this side and this side. So how do we know what those are? Well, if you know anything about a rectangle, you know that opposite sides are equal. So if this side is 2n squared plus 1, the other side then is also 2n squared plus 1. So we'll write that, 2n squared plus 1. And what's this side over here? The opposite side is n squared plus 4n, so this becomes n squared plus 4n. Now, how do we figure out the perimeter? Well, we add all the sides together. So this one's a little bit more. So let's start with this side here. So we get 2n squared. I'd type it, but the little n squared part doesn't come out in typing. 2n squared plus 1. I'm going to add this side here, plus n squared plus 4n. Okay, we've done this side, we've done this side. Now we got to do this side again. Same thing as the other side, right? 2n squared plus 1. 2n squared plus 1. And then the final side is the bottom over here. Plus n squared plus 4n. Okay, we need to simplify this. That's too long. So we have to combine like terms. So I'm going to pick a different color here, and we are going to combine. First of all, let's underline what's the same. Well, we know that n squareds are the same, so we're going to underline all the n squareds and only the n squareds. And then we're going to add them together. If I add up all the n squareds, 2n squared plus 1n squared, that's 3n squared, plus 2 more, that's 5n squared, plus 1 more, that's 6n squared. So that is 6n squared. Now we're going to combine the n's. So do we have any of those? Yes, we have an n here, and we have an n over here. So that would give us 4n plus 4n. 4n plus 4n is, yes, 8n. Right there. And now we're going to combine our constants. So that would be our 1 and our 1. So 1 plus 1 is, you guessed it, 2. So we have simplified the perimeter to be 6n squared plus 8n plus 2. Okay, let's go on from there. Give those a try at home. There's more to choose from there to work on. Let's go to simplifying an algebraic expression. Okay, you can read that on your own. Let's go right to some of the problems. Number 1, on his last birthday, Arnie was 144 centimeters tall. Since that time, he has grown h centimeters. So if you want to think in your mind, put a number in there. He's growing 3 centimeters. So how would you figure out which expression tells Arnie's present height? So we know that he's growing more, so we're going to be adding, aren't we? We are actually going to be adding how much to 144? H, right? So the only one that shows that is C. It's got the H written first, but that doesn't matter, right? H plus 144. So that's the answer to 1. Let's look at number 5. Let's see what that says. Christy lost 5% of her body weight while on a diet. If Christy weighed n pounds before dieting, this one's tricky, which expression tells her weight now? So remember with percentage, first of all, you have to change the 5% to a decimal by moving the decimal 2 to the left. So here's your new decimal, and you fill in it with a 0. So it's something to do with 0.05, right? Now, she weighed n pounds. So if I multiply 0.05 times her current weight, that's going to give me how much she lost, right? But we want to know her weight now, not just how much she lost. So which one of those expressions would show how much she currently weighs after she lost some weight? It would be D, right? Right here, because that says, what does that say in words? It says her first weight, right? That was what she weighed. That's her n. She weighed n pounds. She lost 5% of n, right? So we have to subtract that out from what she was to begin with. So she was n to begin with. She lost 5% of that. So 5% of n. So that's the answer to number 5. Let's look at number 6. Up here one more. Okay, it says if you subtract 6 from the square of Gary's age, the result is Zane's age. If Gary is G years old, which expression tells Zane's age? We know that some kind of expression is going to end up being Zane's age. And the expression we're going to be using is Subtracting 6 from the square of Gary's age. Subtracting 6 from the square of Gary's age. Well, which one can we get rid of for sure? Anything that doesn't have a square for a G, right? So Gary's age, this one doesn't have a square for Gary. This one is kind of different. It does have a square, but it's like that, right? So how do we know? So we're going to subtract 6 from the square of Gary's age. This is subtracting 6 from Gary's age and then squaring it. This one is squaring Gary's age and subtracting 6. So that one is the correct one. I can circle that right there. This one says 6 minus Gary's age and then square it. That's totally wrong, right? Okay, number 10. Let's look at that one because these can be confusing. Marcel, this is number 10, had 4 friends agree to share the cost renting several video games. The rental cost is N dollars. Write an expression that tells Marcel's share. Okay, Marcel's share. And we are going to write, and writing thing here. So N is the total cost, and there are Marcel and how many friends? Don't be tricked on this one. Marcel and 4 friends. So a total of 5 people have to split the cost, right? So N divided by 5. Be very careful when you read through those that you're not tricked on some of those. Number 13, let's go to that one. If you multiply the square of a number by 3 and then subtract 4 from the product, the difference equals Ben's age. Write an expression that tells Ben's age. Well, let's start writing. If you multiply the square of a number n, so n squared, and you're going to multiply that by 3 times n squared, and then all of that you're going to subtract 4. Then that is equal to Ben's age. So 3n squared minus 4. Okay, clear my drawings. Let's see what is next. Okay, a little bit of evaluating algebraic expressions. Hopefully you remember PEMDAS. I don't know if you've heard that when you were in school. This is a simplified version of PEMDAS. What PEMDAS stands for, P-E-M-D-A-S, it stands for the order that you're supposed to do operations in an expression. So first you do parentheses, then you do exponents, then you do multiplying, or dividing on the same level, and then finally you do adding or subtracting on the same level. So I'm going to put these in a line instead of next to each other like this. I'm going to do that so that you can see the order. So that's basically what that's telling you up there. You are doing it parentheses first. We'll give an example. Then exponents, then multiplying or dividing, whatever comes first from left to right, as if you were reading a book. You always read from left to right. Do the same thing with math expressions. And adding, subtracting from left to right, whatever comes first. So let's take a look at some of these. I want to go to page 45 where they have some examples here. And I'm going to move this so that we can kind of keep this up here maybe. We can get it to move over here. And yeah. Find the value of each algebraic expression. I would like to do number 1 to start with. It tells you x is equal to 4. So I am on this one right here. So we are just going to substitute in -4 for x. Okay, and don't get too tricked on this because remember when you had the packet on positive and negative numbers in that, there's a lot of that in algebra. So you just got to remember your rules. So we have a -4 plus a +9. So that's like saying you owe somebody $4, but you have 9 in your pocket. Are you going to be, how much you're going to have left in your pocket? 5, right? It's really 9 minus 4. So the answer to that is 5. That was a very simplified one where we didn't have to really use the PEMDAS. But let's try number 7 where we start getting into some of that. So let's go to number 7. Okay, this whole row is number 7. Let's look at this one right here. 3 times the quantity, x plus 7 equal when x equals 2. So we're going to have to plug in x equals 2 into x right here. So if I do that, I'm going to put a little white space so we have a little bit drawing area here. So if I do that, I am going to get 3 times the quantity of x, which now is going to be 2 because we're substituting 2 in for that, plus 7. So PEMDAS, which I must have cleared, parentheses is first. So whatever's in parentheses we do first. 2 plus 7, that's 9. And that's times by the 3 over here. So 3 times 9 is 27. So that's how you do number 7. Let's look at number 8 right below it here. That's getting a little more complicated again. We're going to put 3 in for x every time we see x. So this time we see x in 2 places, right? We got to plug that in. So we have 2 x squared. I'm just going to rewrite this whole thing, plus 3x. 3x. And then we're going to plug in for x, we're going to plug in the 3, right? So we're going to end up with 2, and use different colors so we can see what we're doing. We're plugging in 3 for x, and that's really 3 squared, right? Plus 3 times, what is x? X is 3. So let's plug that in for x, and that's a 3 right there. Okay, now we solve. So we do exponents first, so parentheses first, but we don't really have any that's expression inside of parentheses. So we do exponents. 3 times 3 is 9. So we have 2 times 9 plus 3 times 3 over here, 9. And then the last step is 2 times 9, that's 18, plus 9 is equal to, right, 27. Okay, they're getting more complicated as we go. Oh, I apologize for my phone going off there. Okay, number 10. Should really put it on silent. Sometimes I forget. Okay, clear my drawings. Let's go and do number 10. Way over here, a division one. Okay, this is a real complicated one. Let me circle that one for you right here. And let's put a little bit of white space so we have some space to write on. Right there. Okay. Drawing. Okay, so z is equal to -1. This one's confusing. Let's not get confused. So let's rewrite this whole thing for z times z minus 4 squared all over, I'm going to use a straight edge here, all over 5 z squared. Z squared. Okay, let's plug in -1 every time we see a z. So we're going to rewrite 4. And now we're going to plug in our z value of -1. So times -1. And all of that, the quantity of times the quantity of z. Now we got a z again. So that's going to be a -1. Z, -1. And that's going to be minus 4 and squared, right? And all of that is over 5 times z squared. So now we're going to put in our number -1. And that's squared, right? Okay, so now what do? Well, we have to solve it. Do what's in parentheses first, PEMDAS, or please, it's another way of saying it is please excuse my dear Aunt Sally. Please, parentheses, excuse exponents, my dear, multiplying and dividing, Aunt Sally, adding and subtracting. So parentheses first, so if I was to solve for parentheses first, I'm going to still have 4, and I'm going to have my -1 still there. And then I'm going to have what's in parentheses. So I have -1 minus 4. What does that mean? Well, it's the same as -1 plus -4. So that's -5. And that's squared. And that's all over 5 times -1 squared. So we'll do the -1 squared. We'll do the exponents first. 5 times, what's -1 times -1? +1. Okay, step by step. Next, we're going to do our exponent up here on the top. So I'm going to come down here and do it. So that's going to equal, so we have 4 times -1. And then what is -5 squared? -5 times -5, +25, right? So now we got to multiply all of those things together on top. And on the bottom, we just have 5 times 1, or 5. So let's finish what we got. So 4 times -1 is -4. And that's times 25. That one you should be able to figure out because 4 quarters in $1. So 4 25s in 100, right? So now negative though, -4 times 25 is going to give you -100 all over 5. What is -100 divided by 5? -20, right? 20, 40, 60, 80, 100. So the answer to that big problem is -20. This answer is -20. That was a doozy. So hopefully you stuck with me on that one. You can feel free to rewind it if you need to and watch it again. Okay, let's go on to using volume and area formulas. Clear this. And let's go to page 49. These are all the different formulas here, what to use. Let's take a look for a minute. Do we have anything up here? No, I'm just going to keep going. This is giving you all the different formulas which you can reference and look back on as you're working on this packet. I would say it's a good idea to memorize some of the common ones like rectangles, area, length times width, area of a circle, circumference of a circle, area of a triangle. Perimeter is always adding the signs around it. And some volume formulas, the volume of a rectangular prism and the volume of a cylinder would be good. Okay, when to use what formula? So this is pretty good. So let's just take a look at that for a moment. This here shows when to use a formula. Oops, don't want that extra one in there. So use the perimeter formula to find the distance around a figure. So around it. Use the circumference formula for finding the distance around a circle. Use area formulas for finding the surface area of a figure. That's the outside of it, right? And use volume formulas for finding the volume of or space inside. So I'm going to underline space inside of an object, okay? So that's how we use our formula. So go ahead and take a look at that at home on your own there. Let's go on and try some practical problems. So let's look at number 1. And I'll hide some of the other stuff so we can only see number 1. Here we are. George is enclosing a rectangular window with molding. How many feet of molding are needed if the window measures 5 feet long by 4 feet wide? So we could draw a picture. I always like to draw a picture feeling like that really helps me visualize. So he's got a rectangular window, and we know that it is 5 feet long. and we know that it is 4 feet wide. And he wants to put molding around the outside of it, nothing to do with the inside, just the outside. So we know we're talking about perimeter. So the opposite side for rectangles are equal, so that will be 5, and the opposite side here will be 4. And then perimeter is just adding the outside lengths together. So 5 plus 4 is 9, and another 5 plus 4 is 9. So it's a total of, he will need 18 feet. Okay, that's an example with perimeter. Let's look at number 6. Here is 6. So let's get rid of all of this extra. A field in the shape of a circle has a radius of 21 meters. Find the approximate area of this field. So we know we want to use the area formula of a circle. The area formula of a circle is equal to, in your packet there, but it's pi r squared. Okay. R being the radius is the line that connects the edge of the circle to the very center of the circle. The diameter is the line that connects one edge of the circle to the other edge of the circle going through the center. So for example, if you have this being your circle, the radius would be here. That's half of the diameter. The diameter would be going all the way across the center. You can have several radii or diameters. Just go through the center. As long as it goes from one end to the other through the center, it's a diameter or a radii. Okay, so we are given the radius of 21 meters. So and then pi, in case you don't remember, pi is 3.14 approximately. It's really a never-ending number. It's an irrational number, but most times you'll just use 3.14 for pi. You could also use 22/7 to get a more accurate evaluation of pi. So pi is 3.14 and r squared, so we have to do 21 and we have to square 21. We have to multiply 21 times itself. 21 times 21, I went ahead and did that for you already. It comes out to 441, and all of that times pi, right? So times 3.14. So 3.14 times 441 gives you about 1,384.74. Now remember, it's never exactly right because of pi not being a rational number. And this is meters squared. Whenever you're talking about area, you're talking about square meters or meters squared. Okay, that's number 6. That's an example with a circle. Let's look at number 7, the one right below it. Carlos rented a moving van that has an enclosed section measuring 18 feet by 6 feet by 7 feet. How many cubic feet of storage space does the truck have? This is an example of using a, do you know it? A volume formula. Yes, so we need the volume of a rectangular prism because it looks like it's a rectangle. So the volume of a rectangular prism is length times width times height. Okay, so we just plug in the numbers. We have 18 by 6 times 6 times 7. So if you multiply 18 times 6 times 7, you get 756 cubic, and make a 6 there, it's a bad 6, cubic feet. So FT is 3. 756, I don't like my 6, it's bugging me. Fix it. 756, that's better, cubic feet. All right, I think the next part is just reviewing. Yes, so I'd like you to work on that on your own as well. So go through the packet and then do the review, and we will see you. So I share here. We will see you next time. Have a good day. Bye.